Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot, and welcome to SAT and ACT Prep. This is stream 3 of Solving with Substitution and Solving Conceptually. In the past 2 streams we've been talking about how to use substitution and conceptual solving practices or processes in order to evaluate multi-statement questions. The first option, we identify the domain of the variables in question. Domain is just a fancy math term for the acceptable inputs or the acceptable numbers that you could use. So that's going to be dependent on the characterization in the question. So if they say that A is an odd number, then that's the characteristic that you have to apply. If they say that A is a positive integer, that means it's greater than 0. So it's going to, there's not one formula, one overarching process that I can recommend to you that's going to apply to every single question like this. It's going to be up to your interpretation. But it's going to first involve identifying the domain, identifying the acceptable values that you can use for any number of variables, choosing those values that are easy to work with, and substituting them into the statements and evaluating whether those statements prove to be true or false, and selecting only the answer selections that contain true statements. The second option, which is the preferred when we solve conceptually, we can understand what is going on in the expression by investigating the relationships between the values, and we can apply the characteristics that those variables or values have in order to obtain some predictable outcomes. So for example, if we're able to understand that when we multiply 2 values together, let's call them A times B, if they tell us that A and B have to be odd and they ask us to evaluate whether A times B will be odd, that would be an odd times an odd. No matter what we choose for A or B, we're confined by the definition or the characteristic that A and B are both odd by the question's context. So if that's the case, we know that they both have to be odd, and if we're multiplying, there's a predictable outcome to all odd values times odd values that will always produce an odd product. And so that allows you to solve these types of problems rather quickly or relatively quickly. And remember, the main constraint that you're fighting on these exams is time. The more time that you can save on any one question, the more time you have on others to maximize your overall score. So let me go ahead and share my screen with you. And first, I just want to review a few number properties that we've mostly gone through before. There's 1 or 2 that I want to mention today. So remember that 0 and 1, also 2, but especially 0 and 1 are very special numbers in the number system. And that stems primarily from the identity and inverse properties of addition and multiplication. The identity property tells us what value will retain the value that we started with, and the inverse property tells us what undoes that value. So, for example, any value plus 0, which is our first characteristic here, first property, any value plus 0 is equal to that value. So that is actually the identity property of addition. That's telling us that 0 is the unchanging value whenever we're adding. When we're multiplying, 1 happens to be that unchanging value, as we see right here. Any number times 1 is that same number. So that's the identity property of addition and the identity property of multiplication, respectively. Also remember, 0 is an even integer, so it's neither positive nor negative. but it is even. 0 is a multiple of every number, so any number times 0 is 0. Therefore, it is a multiple. Every number is a multiple. 0 is a multiple of every number. Like I said before, 0 is neither positive nor negative. That's because positivity and negativity are defined in terms of 0. All values greater than 1 are deemed to be positive. All values greater than 0, not 1, all values greater than 0 are deemed or defined to be positive, whereas all values less than 0 are defined to be negative. So 0 is right in the middle and is the elemental foundational element of those two definitions. So 0 doesn't apply to positive or negative characterizations, and 0 therefore is the only value that's equal to its opposite. 0 is equal to negative 0 or is equal to negative 1 times 0, and that's just 0. So there's no sign associated with it. Any number, 0 raised to any power is always going to be 0. And another alternative here that you have to memorize, and this is rather important, any value raised to the 0th power is 1. The derivation that proves why this is out of the context of this course. It involves a little bit more advanced mathematics. So if you're interested in that, maybe at some point I'll do a video specifically on that characteristic. But for now, just take it as a memorization fact that any number raised to the 0th power will always simplify to just 1. And that is, oops, I'm sorry, I wrote it doubly, so it is very important. I didn't see that there. So a to the 0 power is always going to be 1. Any number times 0 will always be 0. That's a really powerful statement too, because there can be any number of monomials or values that you're multiplying together. You could have 1,000,000 or even 1,000,000,000 values that you're multiplying all together. If any one of those numbers is 0, the whole thing nullifies to 0. So that comes up in a lot of questions that are very logic-based, that have some type of shortcut to where if you input 0, a whole bunch of things that at first look rather intimidating simplify and become quite comfortable to deal with, or at least relatively better. The last two, 0 divided by any number is always 0, but any number divided by 0 is undefined. Remember that division is the separation of items or an amount of something into equal groups. So for example, if I have 6 cookies, if I take those 6 cookies and divide them equally between 2 people, each person gets 3 cookies, because 6 divided by 2 is 3. If I take those 6 cookies and divide them among 3 people, each person would get 2 cookies, because 6 divided by 3 is 2. Even I could divide it by 1. 6 cookies divided or given to one person, 6 divided by 1 is 6. That person would get 6 cookies. But you could not take 6 cookies and divide them among 0 people. It doesn't make conceptual sense, and so any value divided by 0 is undefined in mathematics. It basically, and that's a fancy word for it doesn't work. It doesn't make sense. So you're not allowed to ever divide by 0. For 1, make sure that you understand that a times 1, or any number times 1, is a. Remember that 1 is odd, but it is not prime, because it's the only number that has only one factor. One's only factor is 1, and the definition of prime is that it's divisible by only 1 and itself. 1 happens to be itself, so it doesn't abide by that definition, and so 1 is not prime. That's really important, and that becomes relevant in a lot of evaluation questions. For 2, remember that 2 is the smallest positive prime integer. All other even integers are necessarily divisible by 2, and therefore they cannot be prime, because prime means that they're only divisible by 1 and themselves. So 2 is the only positive, is the smallest positive prime integer, and it's the only even prime. If you have any questions, then please let me know in the comment section below. Otherwise, let's look at a few sum, difference, and product combinations. So anytime that you have an even and you add or subtract to that even number another even value, like 4 plus 2 or 4 minus 2, you will always get an even result. If you take an even number and you add or subtract an odd number, so for example 8 plus 3 or 8 minus 3, you will always get an odd result. Conversely, if you take an odd number and add or subtract an even number, like 7 minus 4, 7 minus 4 would be 3, 7 plus 4 would be 11, you would always obtain an odd result. And then finally, an odd plus an odd, like 3 plus 3 or 3 plus 5, an odd plus an odd will always give you an even result. So if you're asked to test the result of some expression and it involves addition or subtraction, you can identify the characteristic of the values involved and evaluate based on this predictive outcome scenario. So if you have two evens together, you know it's going to be an even. If you have an odd and an even, it's going to be an odd. If you have an odd and an odd, it's going to turn into an even. With multiplication, it's just a little bit different. So an even times an even, like 2 times 2 or 2 times 8, that's always going to be even. An even times an odd, like 4 times 3, that's going to be an even as well. An odd times an even, like 3 times 4, that's also going to be even. Only an odd times an odd, like 3 times 5, will give you an odd result. And I'll move that up there and give you a few seconds to make sure you have that down. If you have any questions, then please let me know. Otherwise, let's just make a few other observations before we get into some problems here. So with addition of positive and negative values in complex sum or difference equations or statements can be simplified by thinking about it conceptually. The value is going to take the sign, the result is going to take the sign of the value with the larger magnitude. Now that can get a little bit complex when you have multiple negatives, and in the next step I'm going to show you how you can use a really practical tool to simplify those really complex double negative problems. But in general, if you're adding two values together and they're opposite signs, the result is going to take the sign of the value with the largest magnitude. So for example, negative 8 plus a positive 5. Negative 8 has a larger magnitude than positive 5, or in other words, the absolute value of negative 8. The distance negative 8 is from 0 on a number line is farther than 5 is from 0 on a number line. So the negativity of 8 is going to overtake the positivity of 5, resulting in negative 3. If you reverse that, if instead we had positive 8 minus 5, now the positivity of 8 is going to overtake the negativity of 5, and we would have a positive result. And by the way, it's true to mathematical nomenclature. Nomenclature is just the standard way of saying, writing, or expressing something in a particular field. If you see a number that doesn't have a sign next to it, it's implicitly positive. Just as if when we say x, we really mean 1x, and really that's the same thing as 1x to the 1 power. It's just that all of those 1s are inconsequential, so we don't write them for simplicity's sake. The same thing is true for a positive sign. So if you don't see a positive sign next to a number, then you know then automatically it's positive. Secondly, so if we have a complex double negative problem, and let me move this up a little bit. So with complicated combinations of positive and or negative values being added or subtracted, you can always use a very practical tool, leave, change, change. So remember that each number has a sign, and then on top of that you have the operator, whether it be addition or subtraction. If you don't see a sign, that's because the number is implicitly positive. So negative 5 minus 8. So really the 8 has a positive sign. The operation is subtraction, but it's negative 5 minus a positive 8. We just don't usually write the positive sign. In order to make, and that might be a little bit strange to wrap your mind around or difficult to mentally process. So we're going to use leave, change, change. Leave the first sign alone, change the operator, change the sign of the second number. Notice that negative 5 plus a negative 8 is a lot easier to think about than negative 5 minus a positive 8, at least for me. If that doesn't help, then you can always use your own method. You can always recognize, also recognize that two negatives make a positive. The only difficulty with that rule is that the two negative signs, the subtraction and an additional negative sign of a number, aren't always next to each other, because it could be the first value and still that's negative and still be kind of confusing to think about. But this is always available to you. Leave the first sign alone, change the operator, change the second sign. It's an exactly equivalent mathematical statement. It's just a little mentally easier to wrap your mind around. Prime numbers, just want to do some reminder of the definition here. So prime numbers are only divisible by 1 and itself. Composite numbers are all other values, or all other numbers with more factors than 1 and itself. And you can tell this immediately by factorizing a value. So for example, if we looked at the value 24, think of two numbers that you can multiply together to get 24. So for example, 6 times 4 or 3 times 8. It doesn't matter which pair you choose. But let's take 6 times 4. We can break those down again as well. So notice 4 breaks down into 2 and 2. 2 is prime, so I can circle. I can't break it down anymore. 6 breaks down into 2 times 3, both of which are prime, so I circle them and I can't break it down anymore, or break those values down anymore. So 24 has a prime factorization of 2 times 2 times 2 times 3. You can almost think of the prime factorization of any composite number as like the passcode, like the key that unlocks that number. The only the prime sequence 2, 2, 2, 3, 2 times 2 times 2 times 3 will equal 24. And only that sequence, and that sequence will never equal any other value. So it's kind of like the passcode that unlocks the value. And you can use prime sequencing or prime values to define all other composite values. Okay, if you have any questions, then please let me know. Otherwise, let's take a look at a few problems. I'm going to give you 5 minutes. I'd like you to look at questions 1, 2, and 3. Question number 1 says, or asks, if x at sine y represents the number of even numbers greater than or equal to x and less than y, what is the value of negative 8 at sine 6? Question 2 asks, if x at sine y represents the number of odd numbers greater than x and less than or equal to y, what is the value of negative 6 at sine positive 11? And question 3 says, if x at sine y represents the number of prime numbers greater than x and less than y, what is the value of negative 8 at sine positive 8? You have 5 minutes. I'll keep track of the time in the upper right-hand corner, and I'll update it per minute. Okay, so let's look at number 1. So if x at sign y represents the number of even integers greater than or equal to x and less than y, what's the value of negative 8 at sign 6? So this is a symbolism question. So remember, they're allowed to make up symbols that aren't technically mathematical operations, as long as they define what those symbols represent. And here they do that. When they basically what they're saying is they're at first listing the format x at sign y. So x represents one number, y represents another number, any number, whatever number they choose to put, or numbers they choose to put. So what they're saying is that the number to the left of the at sign, whenever they put a number to the left of the at sign and to the right of the at sign, it no longer represents those individual values. Instead, it represents the number of even numbers greater than or equal to the one on the left and less than the one on the right. So then negative 8 at sign 6 is asking how many even numbers are greater than or equal to negative 8 and less than positive 6. So let's start with a number line. So I'm going to start over here with negative 8. So I'm going to negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and then we're going up to 6, 3, 4, 5, 6. Now it says less than 6, what's greater than or equal to negative 8, but less than 6. So we can't count 6 itself. So make sure that you acknowledge that. And now we're just counting up the number of even numbers greater than or equal to negative 8, less than 6. So we're going to have negative 8, negative 6, negative 4, negative 2. Remember, 0 is an even number, so you have to count 0, 2, and 4. So we have 1, 2, 3, 4, 5, 6, 7. So the answer to number 1 is 7. There are 7 even numbers greater than or equal to negative 8 and less than positive 6. If you have any questions, then please let me know in the comment section below. Number 2, if x at sign y represents the number of odd numbers greater than x and less than or equal to y, what is the value of negative 6 at sign 11? So now we're going to draw a number line between negative 6 and positive 11. We're going to recognize that we have to be greater than x, so we can't count negative 6, but we can be less than or equal to y, so we can count 11 if it applies to the characteristic in which we're testing. The characteristic in which we're testing is whether the numbers are odd or not. So starting with negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and ending at 11. It has to be greater than negative 6, so we're not allowed to count negative 6, but all of the odd values that are greater than negative 6 or less than or equal to positive 11 would be negative 5, negative 3, negative 1, positive 3, positive 5, positive 7, positive 9, and positive 11. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the answer to number 2. Number 3, if x at sign y represents the number of prime numbers greater than x and less than y, what's the value of negative 8 at sign positive 8? So now we're investigating whether the numbers are prime or not, and we're greater than x and less than y. So we're exclusive to both x and y, meaning we cannot count negative 8 nor positive 8. So I'm going to have negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now, we said that positive and negative 8 are exclusive to the domain. Excuse me there, I had to think about that. Exclusive versus inclusive. So we cannot count negative or positive 6. And we're looking for all the primes in between these two extremes, or these two this maximum and minimum. So negative 7 is prime, negative 5 is prime, negative 3 is prime, negative 2 is prime. Negative 1 is not prime, 0 is not prime, positive 1 is not prime, positive 2 is prime, positive 3 is prime, positive 5 is prime, and positive 7 is prime. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the answer to number 3 is 8. If you have any questions, then please let me know. Otherwise, I'll give you 5 minutes. Please look at questions 4 through 6. Okay, so number 4 asks, if x at sine y represents the number of even integers greater than x and less than y, what's the value of negative 11x at sine 6? So x and y are exclusive to the domain, meaning we cannot count negative 11 or positive 6. But let's go ahead and draw a number line. So we're going to start at negative 11. Negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. They have to be greater than negative 11 and less than positive 6, so we can't count the endpoints here, so negative 11 and positive 6 are out. And then we're looking for the even numbers. So we're going to have negative 10, negative 8, negative 6, negative 4, negative 2. Remember to include 0, positive 2, and positive 4. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 even numbers greater than negative 11 and less than positive 6. Number 5, if x at sine y represents the number of odd numbers greater than x and less than y, what is the value of negative 11 at sine 6? So again, we're still greater than x and less than y. So these two endpoints are still exclusive to the domain, so we cannot count them. So we're going to have negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. But we can't count negative 11 nor positive 6, so those values are out. And now we're looking for the odd values. So we're going to have negative 9, negative 7, negative 5, negative 3, negative 1, positive 3, positive 5. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 numbers that are greater than negative 11 and less than positive 6 that are odd. And number 6, so if x at sine y represents the number of prime numbers greater than or equal to x and less than or equal to y, what is the value of negative 11 at sine positive 11? So now we're greater than or equal to x and less than or equal to y. So these endpoints are inclusive to the domain of x and y, or domain of this to this domain overall. That means that we can include them. So we're going to have negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We can include the endpoints, so we're not going to eliminate anything out of this number listing. And now we're looking for the prime numbers. Negative 11 is prime. Negative 10 is not, negative 9 is not, negative 8 is not, negative 7 is prime, negative 6 is not prime, negative 5 is prime, negative 4 is not prime, negative 3 is prime, negative 2 is prime, negative 1, 0, and positive 1 are not prime, positive 2, positive 3, positive 5, positive 7, and positive 11 are all prime numbers. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 primes greater than or equal to negative 11 and less than or equal to positive 11. If you have any questions, please let me know. Otherwise, let's take a look at these problems here. I'm going to give you 3 minutes. I'd like you to answer question number 1. So question number 1 says, if A and C are odd positive integers and B is an even positive integer, which of the following would be even? Statement 1 says A times B. Statement 2 says A times C. Statement 3 says B times C. And then the answer selections are A, statements 1 and 2 only, B, statements 2 and 3 only, C, statements 1 and 3 only, and D, statements 1, 2, and 3. I'll give you 3 minutes, and then I'll give you the answer. Okay, so if A and C are odd positive integers and B is an even positive integer, what we can do, we could either identify these values as such so that they're either odd or even and they're easy to work with. So for example, we could pick A and C to be 3 and 5, respectively, and maybe C to be 2. Those values abide by the characteristics that are listed in the question. And so we can substitute those values into the expressions and see which of the expressions would result in an even output. Those statements, those corresponding statements, would be the correct answer. However, we want to, so that's one way. We could say that A is equal to 3. We could say that B is equal to, C is equal to 5. And maybe B is equal to 2. Those are easy to work with numbers that abide by the definitions provided of A, C, and B. However, we want to be able to solve conceptually. That's usually the fastest method, or in that case, the faster method, because we're only comparing two things. A times B. We know that A has to be odd, so this is really just an odd times B is even. If you take any odd and multiply it by any even, it will always result in an even number. So statement 1 is true. Statement 2, A times C. So A, again, that's odd. C is also odd. An odd times an odd will always result in an odd. So statement 2 is not true. So I know that statement 1 is true, so I can eliminate answer selection B because it does not contain statement 1. And I know statement 2 is false. So any statement that has statement 2 in it, in other words, I know that the answer now has to be answer selection C because it's the only one that doesn't have 2, statement 2. But let's just go ahead and prove statement 3 is false. Prove that statement 3 is true. B times C, so B has to be an even number and C has to be an odd number. An even times any odd will result in an even, so statements 1 and 3 are true. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. Take a look at question number 2, which says if A and C are even positive integers and B is an odd positive integer, which of the following would be odd? Statement 1 says the quantity A times B minus the quantity B times C. Statement 2 says 2 times the quantity A times B, quantity minus 3. Statement 3 says 5A times the quantity 2C plus 3B. Statements A, B, and C respectively are statements 1, 2, and 3 only, and answer selection D rather is statements 1, 2, and 3. You have 3 minutes. So if a and c are even positive integers, if we wanted to use substitution to solve, maybe we could pick a to be equal to 2 and c to be equal to 4. Those are both even positive integers. And if b is an odd positive integer, maybe b is equal to 3. That's also easy to work with, and positive and odd. So you could substitute these values in and evaluate to see which of these statements would turn into odd results. But we want to solve conceptually. So a times b, the quantity a times b, that's equal to an even times an odd, minus b times c. That's going to be an odd times an even. An even times an odd is going to be even. An odd times an even is also going to be even, and an even minus an even will always result in an even answer. So statement 1 is false. If statement 1 is false, then we know that answer selection A and answer selection D cannot be true. So we can eliminate A and D. Statement 2, 2 times the quantity AB minus quantity minus 3. So it doesn't matter that they're inserting actual numbers here. Just evaluate the numbers in terms of their characteristic, or their corresponding characteristic. So 2 is an even number, so this is going to be even times the quantity of A times B. A is even, B is odd, minus an odd, because 3 is an odd number. Working inside the parentheses first, so an even times an odd will always be an even. So this is going to turn into an even times an even, quantity minus an odd. An even times an even will always be even, so this is going to evaluate into an even minus an odd. An even minus an odd will always result in an odd outcome. So statement 2 will be odd. So you can tell by the answer selections that answer selection B is the correct answer because it's the only answer selection that contains statement 2 but does not contain statement 1. Let's go ahead and check statement 3 though, just for demonstrative purposes. That means to demonstrate. 5a times the quantity 2c plus 3b. So 5 is an odd number, times a, which is an even number, quantity times 2, which is an even number, times c, which is an even number, plus 3, which is an odd number, times b, which also has to be an odd number. So you just need to pay attention to order of operations here. Outside the parentheses, we have an odd times an even. That will always result in an even. I'm sorry, let me scroll up here. Inside the parentheses, make sure that you do multiplication first. So an even times an even will produce an even. An odd times an odd will produce an odd. Inside the parentheses, so this even on the outside is just going to carry through for now. Inside the parentheses, an even plus an odd will result in an odd. An even times an odd will result in an even. So statement 3 is not true, and therefore C, answer selection C is not true, and so your answer here is going to be B, statement 2 only. If you have any questions, please let me know. Otherwise, let's look at question number 3, which asks, A, B, and C are positive integers. If C is less than A is less than B, it should say and, but if C is less than A and A is less than B, then which of the following is or are negative? Statement 1 says C minus A. Statement 2 says A minus B. Statement 3 says B minus C. Answer selection A is statements 1 and 2 only. Answer selection B is statements 2 and 3 only. Answer selection C is statements 1 and 3 only. and answer selection D is statements 1, 2, and 3. I'll give you 3 minutes, and then I'll give you the solution. Okay, so A, B, and C are positive integers. That means that they're greater than 0 and that they're whole numbers. And we know that C is less than A, which is less than B. So we could, they're just positive whole numbers, so if you wanted to pick values, maybe C could be equal to 1, A could be equal to 2, and B could be equal to 3. Those values satisfy the relationships established in that inequality, C less than A less than B, and they're positive integers. So you could sub in here and just check to see which of these are negative, but we want to start solving conceptually. So what I'm going to think of is that I'm going to think the C is the small and that B is relatively large. So C minus A. C is a small number, and relative to C, A is larger, so I'm going to just call it relatively large. Anytime you have a small positive minus a large negative, that's going to produce a negative result. So statement 1 is true. If statement 1 is true, then answer selection B cannot be true. Statement 2, A minus B. So relative to A, B is relatively large. So again, this is going to be a small minus a relatively large value, which must result in a negative result or a negative outcome. So statement 2 is true. So if statement 2 is true, answer selection C does not contain statement 2, so it must be false. So now we just need to check statement 3. We have B minus C, so we have a relatively large number minus a small number. That, if they're both positive, will always result in a positive outcome. So statement 3 is false, and our answer here is going to be 1 and 2 only. If you have any questions, then please let me know. Otherwise, let's look at question number 4. Question number 4 asks, A, B, and C. Excuse me, I'll give you a few seconds to make sure you have all the work done. So question 4 asks, A, B, and C are negative integers. It should be a period again, I'm sorry. If C is less than B and B is less than A, then which of the following is or are positive? Statement 1 says C times the quantity A minus B. Statement 2 says A times the quantity B minus C. Statement 3 says B times the quantity C minus A. And answer selections A, B, and C are statements 1, 2, and 3 only, respectively. So A is statement 1 only, B is statement 2 only, C is statement 3 only, and answer selection D is statements 1, 2, and 3. So I'll give you 3 minutes, and then I'll give you the solution. A little hint, you might want to use substitution here because you're involving subtraction and negative values, because A, B, and C have to be negative. So to try and do this one mentally might be a little tricky, and it could involve provide a great opportunity for you to make a careless math mistake. So I would recommend plugging in acceptable values given the domain of A, B, and C. But I'll give you 3 minutes, and then I'll give you the solution. Okay, so if A, B, and C are negative integers and C is less than B, which is less than A, then maybe we could pick C to be -3, B to be -2, and A to be -1. Remember that negative values are counterintuitive, meaning that the higher their magnitude, the less their value. For example, -100 is a smaller number than -1, or conversely, -1 is a larger number than -100, because -100 is farther to the left, farther away from 0 on the number line. So just remember that it's a little bit tricky if you start doing this mentally with negative numbers, so that's why I recommend substituting in here. So if we sub in, we'd have -3 times the quantity of -1 minus -2. We could do leave, change inside these parentheses. Leave this guy alone, change that guy, change that guy. -1 minus a -2 is the same exact thing as -1 plus a +2. So this is going to turn into -3 times +1, which is -3. That is not positive, so statement 1 is false. So we know that answer selections A and D are not true. Statement 2, subbing in, we'd get -1 times the quantity -2 minus -3. I'm going to do leave, change. Leave this guy, change that guy, change that guy. -2 plus a +3 is going to be a +1, so we're going to have -1 times a +1. That's going to give us a -1. That is not positive, so statement 2 is not true. Therefore, we know the answer here has to be C, statement 3 only. But let's go ahead and check. Subbing in, we're going to have -2 times the quantity -3 minus -1. If I do leave, change, leave that guy, change that guy, change that guy, we're going to end up with -2, -2 times, -3 plus a +1 is going to be a -2, so we end up with -2 times -2, which is a +4. That is positive, so our answer is indeed answer selection C, statement 3 only. If you have any questions, as always, please let me know in the comment section. And this brings us up to question number 5. This will be the last question for our session today. Question 5 asks, if A and B are positive integers and 12A minus B is equal to 27, then which of the following must be true? Statement 1 says A is odd. Statement 2 says B is even. Statement 3 says 3 times AB is odd. Answer selection A is none. No statement is true. Answer selection B is statement 1 only. Answer selection C is statement 2 only. And answer selection D is statement 3 only. So I'll give you 3 minutes and then I'll give you the solution. Okay, so we can solve this problem as well two ways, using substitution or solving conceptually. So if we were to solve using substitution, notice that there's a 12 that's being attached to A or being multiplied into A. That's going to expand pretty quickly, and notice what this overall thing is saying, that 12A minus B is equal to 27. So if 12A can expand pretty quickly, so for example, let's just test a few values, starting with the smallest positive integer, which is 1. Let's say that A is equal to 1. If A was equal to 1, then 12 times 1 minus B would be equal to 27. And so we would get 12 minus B is equal to 27. Subtracting 12 on both sides, I'd get negative B is equal to 15. So B would be equal to negative 15. However, A and B have to be positive integers. So that does not work. So I have to discredit that. I'm going to move on to see test if 2, the next greatest positive integer. So if A is equal to 2, then I'd have 12 times 2 minus B is equal to 27. 12 times 2 is 24, so I get 24 minus B is equal to 27. Subtracting 24, I get negative B is equal to 3, so B would be equal to negative 3. So if A is equal to 2, then B would have to be equal to negative 3. That can't be the case either, because A and B both have to be positive. So if I keep going, A is equal to 3. If A is equal to 3, then I'd get 12 times 3, minus B is equal to 27. 12 times 3 is 36, so 36 minus B is equal to 27. Subtracting 36 on both sides, I get negative B is equal to negative 9. Multiplying by negative 1 on both sides, B would be equal to 9. So notice that when A is equal to 3, B has to be equal to 9. If I continue this one more time just to check what would happen, if A is equal to 4, 12 times 4 minus B has to be equal to 27. 12 times 4 is 48, so we get 48 minus B is equal to 27. Subtracting 48 on both sides, 27 minus 48 is going to be a negative 19. Let me just check that. Negative 21. 27 minus 48, negative 21. That's what I thought. Negative 21, so multiplying by negative 1 on both sides, then B is going to be equal to positive 21. So when A is equal to 3, B has to be equal to 9. When A is equal to 4, B has to be equal to 21. Notice that A can be positive and or negative because it equaled 3 and 4. So statement 1 is not true. Statement 2 says B is even. B is not even. In both cases where this worked, and if you continue to test values here, like A is equal to 5, you'll see that B will always be odd. So this is not true either. And statement 3 says 3 times A times B is odd. Well, what we have here is 3 is an odd number, right? We found out that B has to be an odd number. However, A can be even or odd from this scenario. If A can be even or odd, then 3 times A times B could be even or odd as well. If A were to be odd, then we would have an odd times an odd times an odd, and that indeed would be an odd answer. But notice how they say must in the question. If they say must, then that means there's no situation in which this statement is false. If A were to be an even number, then we would have 3 times an even number, or an odd times an even, which would be an even. Then that even result times another odd would again result in an even. So it depends on the value of A, and because A could be even or odd, the result of 3 times A times B could also be even or odd. There's no reason why it must be odd. It could also be even. So statement 3 is also false. So our answer to number 5 is going to be A, which is none. No statement listed is true. If you have any questions, then please let me know in the comment section below. If you find my video these videos helpful, then please like and favorite the video and subscribe to my channel. I really appreciate everybody participating. And if there's no other questions, then Tater Tot, let's see if Tater Tot wants to say goodbye to everybody. Come on, Dr. Tot, you want to say goodbye? I know, it's past your bedtime. Come on. You want to say goodbye to everybody? Up, up, come on, up. Can you do a paw? Yes. Okay. Very good. I think Dr. Todd is a little tired. Well, thank you guys very much for signing in and or watching my recording. If you have any questions, please let me know. Otherwise, I'm Mr. Matt. That's Dr. Todd. Please subscribe to my channel if you found it helpful. I'm here for you every day, 3 p.m. to 8:45 p.m. Eastern Standard Time. And you can check me out in my Facebook, where I announce details on the next broadcast in the description below. Thank you guys. Have a great night, and I'll talk to you soon.